Okay, so today we're going to be moving on to 10.3, which is volume. So volume is the space inside an object, pretty much. The space that it takes up, not just the surface, but the space inside, okay? So the volume is the amount of three-dimensional space an object occupies. The units for volume often include the word cubic, cubic inches, cubic centimeters, and so on. So these can be written with an exponent, so inches cubed, centimeters cubed, feet cubed. Like, you know how in area we always have something squared as our units? Now for volume it'll always be something cubed. Other units in volume are gallons and liters and have no special notations, okay? Because gallons and liters are already symbolize the space that it takes up, the three-dimensional occupation. All right, moving on, here we have a prism and a cube in front of us. So it says we can calculate the volume of a regular solid as the product of its base area, the length and width, and its height. As long as the upper and lower bases are the same, we use V for volume. Okay, so that pretty much is saying volume equals base area times the height, or volume equals length times width times height. This is typically the one I tend to go for, just because if I see B, I tend to think one value, and this just puts all three of those values right into perspective. Okay, so let's calculate this first red prism here. Okay, volume equals length times width times height. So volume equals 12 times 5 times 3. We get 180 inches cubed. Remember, to the power of 3, because we're in volume now, okay? Okay, now for this cube here, volume equals length times width times height, which equals 4 times 4 times 4. So volume is 64 meters cubed. That's it. That's all it is. Length times width times height. Those are really straightforward and nice and pretty. All right. So with a single cube, we multiply its length by its width by its height to calculate its volume. If we have many cubes, we can combine their volumes by multiplying volumes. Okay? So this has said, find the volume when each cube is 8 centimeters squared. All right, so this is a weird context, I know, but it's sort of like if I have two boxes next to each other, the volume is both those together. So in all of these boxes, we can just take the volume of each box and find the total volume. All right, so first thing we have to look at is number of cubes. Okay, how many cubes do we have? So we have 3 cubes here, times 5 cubes here, times 2 cubes here. We just multiply those like we're finding the volume in cubes, sort of. So 3 times 5 times 2, and we have a total of 30 cubes. Now, it says that the volume of each cube is 8 centimeters cubed. So, volume is going to be the 8 centimeters cubed times 30 cubes. So our total volume is going to be 240 centimeters cubed. Okay, so you're just finding the volume using in cubes and then using those to find the volume in units along with the volume of each cube. Okay, so remember, we can multiply the length by its width and its height to calculate its volume, and then combine the volumes by multiplying. All right, let's move on. All right, so let's look at the volume of prisms and cylinders. So the volume of a prism and a cylinder can be calculated as a product of its area of its base and its height. Okay, so basically it's saying that volume equals base area times height. And remember that B is base area and H is height. Okay, so that is important because that right there is our formula for this. So here, let's look at this rectangular prism we have here. Volume equals base area times height. And here, our base area is a rectangle, so it's just going to be length times width times height. No surprise, considering what we just looked at for our cubes and rectangular prisms. So 7 times 3 times 5, we get 105 inches cubed. Easy. Moving on. All right, here, volume equals base area times height. Volume equals 1/2 base times height, which is 5 times 8, right? Because our base is the triangle right here, 5 and 8. That's our base. And our height is going to be 10, because that's the lateral length, so 10. So put it all in the calculator and we get 200 meters cubed. All right, so you just have to pay attention to what your base shape is. That's why we have a half here. You have to remember that you're looking at a triangle as your base shape. All right, let's look at the cylinder. Volume equals base area times height. Volume equals our base area. So our base is a circle, right? With a radius of 5. So pi times r squared times height. Radius is 5, so 5 squared, and our height is 8. Put in the calculator and we get 628.3 feet cubed. All right, so if you remember the formula base area times height, it's great because you can use any 3 sort of prisms that you could be given, and you won't have to remember the little variances and differences within the formulas. As long as you know your regular area formulas, you can figure out the volume of a prism. All right? All right, so let's look at the volume of pyramids and cones. So with the surface area formulas we discussed earlier, the pyramids and cones had to have regular polygons like a square as a base. With volume formulas, we can drop that requirement. Okay, because there's only one base here. So we're sort of realizing that for these, it's going to be 1/3 of the area because of this space that we're not including. The space around the shape. It's sort of like we're finding the volume of the prism, but then we're only taking 1/3 of it because we're not having the entire shape. We're only having part of it. So what you have to know is when we're doing cones and pyramids, volume is 1/3 base times height. Now let's find the volume of each of the following figures we have here. So let's start with the pyramid. So remember the formula is volume equals 1/3 base area times our height. So volume equals 1/3. Our base area, our base here is just a rectangle. So all we have to do is 5 times 4. That's 5. And multiply that by our height, which is 9. So put that all into our calculator, 60 millimeters cubed. Okay, that's it. Same formula we use over here for the cone. So volume equals 1/3 base times height. Volume equals 1/3, oh, this is supposed to be capital B, sorry, because it is base area. So our base is a circle here, so it's going to have to be 1/3 times, and our base area will be pi r, which is 10, squared, times 21, which is our height. Put that all in, we got 2,199.1 inches cubed. All right, straightforward. just using the formula. Okay, let's look at this next problem. So a Great Pyramid of Khufu, I don't know how to say that, sorry, is the last of the 7 wonders of the ancient world still standing. It has a square base, which is important for us to know. We estimate its original dimensions appear in the diagram. What was the original volume? Easy, right? Volume equals 1/3 base area times the height. Volume equals 1/3. Our base area is going to be 230 meters times 230 meters because we know it's a square base times our height, 147. We end up with 2,592,100 meters cubed. So this is awesome because this is real life. Okay, it's something to be curious. How much space are we taking up? We can do it for all different kinds of shapes and buildings and, whatever. Finally, let's look at the volume of a sphere. Okay, so here, this is the formula I just sort of have to know. Volume is 4/3 pi r cubed. Anytime you see a sphere, you use the shape. All you need to know is the radius. If they give you the diameter, make sure you look for the radius, okay? And remember, the radius is from the center to any point on the entire sphere. So, all we have to do is plug it in. Volume equals 4/3 pi times r, which is 5, cubed. And remember, it's cubed because it is in cubic metrics. So anytime you have an exponent in a formula, it should match up with what your units are supposed to be. So if you're thinking, oh my god, I don't know if this is squared or cubed, think this is volume, our answer has to be cubed, therefore our radius will also be cubed. Okay? So we plug all that into our calculator, and the question says to round to the nearest hundredth. Oh, and it also says in terms of pi and to the nearest hundredth. So we'll get 500 over 3 pi centimeters cubed, or 523.6 centimeters cubed. If you haven't found an answer in terms of pi in a while, remember you're just doing all the math except for the pi, and then writing the pi in, and then you just multiply by the pi to find it to the nearest hundredth. Alright, this is it for volume. I honestly think it's a little simpler than surface area, so I think you guys should be fine here. Okay?